So for question 43 from the homework, we're given the information that we have hydrogen reacting with carbon dioxide to form water, carbon monoxide. And then the trick is, and they give us the equilibrium constant for that, 1.6. And they ask for equilibrium concentrations of all of these. The trick is they tell you in the reaction that we have 1 mole of each of these in 10 liters. So a lot of the previous questions that we did gave you concentration already. Here, you have to find concentration. So here's moles in 10 liters. So we have to find molarity for all of these. So molarity is moles divided by liters. So we have 0.1 molar for all of these gases in the reaction. The hydrogen, the carbon dioxide, the water, and the carbon monoxide. Those are our initial concentrations. So then we can set up our ice table and put those initial concentrations for all 4 of those gases. So you're going to see in a second that this problem is more of an algebra problem than a chemistry problem. So here's our initial concentration, right? 0.1 molar for everything, for our products and for our reactants. Just a rare case where we have reactants in the reaction to begin with. And we know our equilibrium constant, right? That's what we need to know, our equilibrium constant to do anything with this problem. And then it asks for our equilibrium concentrations of all of these gases. So first, I would set it up in terms of X, right? So hydrogen reacts, we lose X. Carbon dioxide, they're 1 to 1. So I'm going to subtract X for both of those. And again, our product is 1 to 1 as well. But here we're going to add X to both sides, because we're making our product as the reaction goes at the cost of our reactants. So as an equation, right, it would be 0.1 minus X for our reactants and 0.1 plus X for our product. Now we want to write our equilibrium expression for this reaction and then basically plug in what we know for each of these equilibrium concentrations. 0.1 minus X for our reactants and 0.1 plus X for our products. So using the reaction, right, equilibrium constant always equals products over reactants. So the concentration of hydrogen or of water times the concentration of carbon monoxide divided by the concentration of hydrogen times the concentration of carbon dioxide. We know equilibrium constant, and we know what our equilibrium concentrations, how we would find them. So we set up everything, right? 0.1 plus X times 0.1 plus X for both of our products, divided by 0.1 minus X times 0.1 minus X for both of our reactants. And here's where it becomes more of an algebra problem, right? We notice these are the same, so if we multiply them together, it's kind of the same way as saying I've got 1.6 equals 0.1 plus X squared divided by 0.1 minus X squared. And so now, right, we've got both of these are squared. I can get rid of that by taking the square root of both sides. So if I take the square root of 1.6, I take the square root of this, I get rid of the squared, and I basically have the square root of 1.6, which is 1.26. So that equals 0.1 plus X divided by 0.1 minus X. Now to solve for X, I'm going to take this, right? I'm dividing by it, so I'm going to multiply across both sides by 0.1 minus X. So that's going to give me 0.126 minus 1.26 X. When I multiply that across, that equals 0.1 plus X. From here, again, still just algebra. We want to get X together. We want to get the numbers together. So, we're going to add across the 1.26X. I'm going to add it to this X over here. All right. And I'm just going to do both operations at the same time. So if I'm putting X on this side, I want to get the numbers on the other side. So minus 0.1 from here means I'm going to subtract 0.1 from this side. So my final equation is going to be 0.026 equals 2.26x. Now I can divide both sides by 2.26 and I can get x by itself. Right, and so from that we can see that x equals approximately 0.0115. From there, we want to take this up and go into our equilibrium, how we're going to calculate the equilibrium concentrations, and then do that exact math. So to find the concentration of hydrogen or carbon dioxide, we're going to take 0.1 minus 0.0115. And then for our concentration of hydrogen, we're going to just add it in. All right, so we subtract that, I get 0.0885, 0.0885 for both of our equilibrium concentrations of hydrogen and carbon dioxide. And then here I'm going to add it in to the 0.1, add it into the 0.1, and so I get a concentration of 0.112 molar for both the hydrogen and the carbon monoxide on this problem. So again, it's more algebra based than anything else, right? It is quite a long problem, but what we're able to work through it, more of like an algebra-based question. That being said, definitely on the exam, I would give you equilibrium concentrations and not expect you to do more of an algebra-based question like this.